So in this problem, it is given that the angle between the line A conjugate Z plus AZ conjugate is equal to 0, alright, and its reflection in the imaginary axis is what, alright. So, or rather, it is given that it is equal to this, right, as a very complicated expression is looking like, okay. But just hold your horses, it's not really that complicated, alright. If it is given in this form, then what is the value of this constant K, right? That is the question, right. Now, uh, I would advise the students always to look at every question as simply as possible, right? As you can understand, right? So now when it is given that the line is like this, that is A conjugate Z plus AZ conjugate equals to 0, right? Then do whatever you are able to understand, right? Some students understand it like this, that let us say Z is equal to X plus iota Y. Always Z is X plus iota Y. So then A conjugate Z plus AZ conjugate can be written as, I will break the Z into X and Y so that this becomes A conjugate times X plus iota Y plus A times X minus iota Y equals 0. And then I will take, whatever is with X common with X, that is A conjugate plus A plus Y times A conjugate I minus A I, right? Can you see that? Equals 0. I've taken the X with the A conjugate plus A with the X. So I'll get A conjugate plus A. With the Y, I'll get A conjugate I minus AI. So I'll take the I also common, and then you will see that I'll get this expression. That is A conjugate plus A times X plus iota times A conjugate minus A times Y equals 0. Now, if you know basics of complex numbers, then you will realize that the conjugate of a complex number plus itself is actually a real number. Okay, because A conjugate would have been A1 minus A2i, right? Plus the A itself would have meant A1 plus A2i. So if I was to add these two, my imaginary part will go away and I'll be left with only 2A1, which is a real part. So therefore, if I add this, I will get a real part of A times X. And if I add these two, then I'll get imaginary part of A times Y equals 0. So as you can see, this is now looking more like a straight line that we know, right? Something X plus something Y equals 0. Can you guess which point this line always passes through? Yes, because there is no constant quantity here, it passes through the origin. Also, can you guess what the inclination of this line will be to the x-axis? The tan phi, that is the slope of this line, will be given by minus real of A upon the imaginary part of A, right? Because if I take the x on the other side and if I divide the imaginary part of A, I will get an equation of the form y equals mx, where m is the slope. So therefore, the inclination of this line with the x-axis will be given by minus the real part of A upon imaginary part of A. So in the next page, you will realize that this is exactly what I've written. Also, now I need to find what the slope of the reflected ray is going to be. So in the next page, I have drawn a small figure over here that if this is the incident ray, okay, this is the incident ray, and it is getting reflected about the imaginary axis, just like the question says. This is the imaginary axis. If this incident ray is getting reflected about the imaginary ray, then if this is the inclination of the incident ray, theta, then you can see that this line, okay, and this line both are parallel to each other. Okay, these two lines are parallel. Therefore, this angle plus this angle will be equal to how much? 180 degree. If this plus this is 180 degree, let us say this is alpha. So theta plus alpha equals 180 degree. So how much is alpha going to be? 180 minus theta. And since this is the incident ray, this is the reflected ray, and this is the normal, right? Then I can say that this angle alpha is equal to this angle. Hence, this angle can be written as 180 minus theta, right? And this normal, as you can see, happens to be parallel to the x-axis. So what is the inclination of the reflected ray? with respect to the x-axis, that is the slope of this line, it will be nothing but 180 minus theta only. Right? I hope you have understood that if theta is the inclination or the slope of the incident ray, all right, then the corresponding slope of the reflected ray will be 180 minus theta. So I then go on to find the tan 180 minus theta. All right, and that will be given by the real part of A upon imaginary part of A. So the next step would be to find the angle between these two lines. So if this is 180 minus theta, this is 180 minus theta, the total angle between them will be given by 180 minus theta, all right, plus another 180 minus theta, and that will be equal to 360 minus 2 theta. So therefore, the tan of 360 minus 2 theta will be equal to how much? Will be equal to minus tan 2 theta only, because this is the fourth quadrant. And that is exactly what we found over here. The tan inverse of minus tan 2 phi equals tan inverse of, then I open up the tan 2 phi, right? I open up the tan 2 phi because I don't have to find tan 2 theta. I have to find tan inverse of it. I have to find the angle between them. So then I open tan 2 phi and I'll get minus 2 tan phi upon 1 minus tan square phi. And then I just put in the value of tan phi, which I had calculated here, into my expression, and I will get the answer as tan inverse of this entire quantity. So as you can see, I think this is what we had wanted, the k, and therefore the correct answer is